12.1e, rules for antiderivatives. The first one is the constant rule. Now the constant rule is something we've already used. We're just going to put it in the form of a rule. This case stands for a constant number, dx, and that's just going to equal kx plus c. An example of this, if we integrate 7 dx, that's going to equal 7x plus c. Next, the power rule. We've done this one as well. If we're going to integrate x to the n dx, this is going to equal x to the n plus 1 times 1 over n plus 1 plus c. Okay, an example of this, if we have x squared dx, this is going to equal x to the, we add 1, so we have 2 plus 1 over 1 over 2 plus 1 plus c. All right, and of course that's just 1/3 x cubed plus c. Next, we have an exponential rule. Exponential rule. Okay, now this is for base e. Okay, if we're going to integrate e a to the x dx, that just equals 1 over a times e a to the x plus c. Now this is true, notice where a does not equal 0, which makes sense. Why would they give us 0 anyways? Okay, so let's do an example of that. If we integrate e to the 5x dx, then we're going to bring the 5 down, e to the 5x plus c. All right, now how can we check this is right? Well, let's take the derivative, and that'll check to see if we're right. I'm going to erase this right here. We're going to do the derivative just to see. So we're checking. Okay, if we take the derivative here, we keep e to the 5x, right? We have 1/5, we keep that too, and then we take the derivative of the exponent times 5. Now if we multiply this by 5, you can see this is 5 over 5 e to the 5x, and that just equals e to the 5x. Okay, let's do one more rule. This is the last one. Okay, this is the natural log rule. Natural log rule. Okay, and that is, if we integrate 1 over x dx, all right, that is going to equal ln of x plus c, and this is for, of course, x greater than 0. Now, if we have x in the denominator, x could be negative, but it must not be equal to 0. But for ln x, we know that x must be greater than 0. Log functions, the domain must be always greater than 0. Okay, so if we are not told it's greater than 0 when we're working on a problem, then we have to do this for our answer. Okay, so now I'm going to give you a hint about a homework problem. It's going to take up a little space here. So here's a hint for homework. Okay, you'll be given a problem something like this, where we have 2x to the 4th plus 3x plus 4 all over x. Something like this. All right, where we can see we've got this fraction here, and we're going, wait a minute, how do we deal with that? Well, the best way to deal with that is we're going to go ahead and change this to 2x 4th over x plus 3x over x plus 4 over x, all of that to dx. So notice we're doing the opposite. When we add fractions, we have the same denominator, right? When we have the same denominator, we just write it once, and then we add everything on top. So we're just going the other way. We're splitting it up. Now, after we split it up, we're going to simplify it, okay? So the x cancels out. We have 2x cubed plus 3 plus 4 over x dx. And now we can integrate each separately. So this equals the integration. I'm going to bring out the 2 because it's constant. X cubed dx plus the integration of 3 dx. Bring out the constant, integration of 1 over x dx. Now for simplicity, I would state this problem the same for x greater than 0. Okay, so now we know x is greater than 0. Let's continue our integration. We're going to keep this 2. We know we're going to add 1 to 3, so that's going to be 4, and we're going to divide by that number. Okay, the integration of 3 is just 3x. Here we're going to keep this 4, and this ends up being ln of x plus c. We have a plus in here as well. And that's the answer. Oh, of course, you change that to 1/2. Let's go ahead and do that so we can finalize our answer. All right, there you go.